Hello, everybody, and welcome to your first introductory chemistry or Chem 103 lecture. I am Dr. Aaliyah Hefner, and I will be the wonderful voice narrating you through the 10 or so chapters that we're going to cover in this course. I know that we haven't met yet, or maybe you're watching this a little bit late and we already have met. Hello. This first lecture is going to cover some of the skills that you're going to need for this class. So we're talking about some basic math skills. We're going to talk about significant digits. We're going to talk about measurements versus exact numbers. And this is a good time to kind of gauge your relationship with your calculator. And we'll talk about that more in person, but you will need to know your calculator well, and you'll need to know how to use it well so that when it comes time to do assignments and exams, you're not like question mark, okay? So here we go. First, we're going to talk about measurements. Any measurement that you take is going to be acquired by some kind of an instrument. And that instrument is going to give you a measurement that has a certain degree of inexactness or uncertainty. So I always use this example with the clocks. We don't use analog clocks anymore. At some point, somebody's going to be like, excuse me, Dr. Hefner, what's that? I know we use digital everything. You're looking at your phone, your Apple Watch, whatever. But just bear with me for a moment. If I asked you to use one of these clocks, either the one on the left or the one on the right, to tell time, which one would be easier? You're probably going to say this one on the right. And the reason is it's got all those extra tick marks. So you can tell not just the hour really easily, but you can also tell the minute very easily, and it's got a second hand. So it's got a lot of information on it. That clock has a lot of certainty, which means this other clock that just has the 1 through 12, this one is very uncertain, okay? I would not want to use this clock because I'd be staring at it, struggling, looking at my fingers and my toes like, help me, y'all. When you think about the term uncertainty, what you really want to think is fewest decimal places. I'll give you another example. Let's say that you were going to take a little piece of iron and put it on a scale. Scale 1 gave you a mass of 1.27 grams. Scale 2 said 1.2695 grams. Fewer decimal places means that there's more uncertainty. We'll throw a more up there. So what we're really talking about is how many decimal places, how many digits can you measure with whatever instrument for whatever measurement you're trying to take. And we'll talk about this some more. But just when you think uncertainty, think fewest decimal places. When we're talking about measurements, we need to give you some terms. We're going to be using the metric system for the most part because we're doing chemistry. The metric system is easy. We're going to talk about it in Chapter 2. We're going to do a lot of work there to learn how to convert units and things of that nature. But for now, I want you to know the three types of measurements. We've got length measurements, mass measurements, and volume measurements. Some examples of the units that we'll use for these is length. You might see centimeters, meters, something like that. For mass measurements, you're going to see some kind of grams, kilograms, milligrams, something like that. And for volume, you're going to see some kind of liter, milliliter, liter, deciliter if you're in the healthcare profession. So those are some examples of the different units that we see, but you'll certainly need to know the three types of measurements. Now, when I tell you should know something, that means like for real know it. Not trying to trick you or tell you should know it, and then it doesn't end up on any assignment or any exam or anything. I'm pretty straightforward like that. So please, 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 as you're taking your notes, when I say, hey, this will be on the exam, or you should know this, put a big old star or highlight it or circle it or something like that, and make sure that that's one of the things that you focus on when you study. When we're talking about measurements, we have to talk about significant digits, or what I'm used to calling significant figures. And when I was in chemistry, moons ago, we called the significant figures or sig figs. I'm going to keep calling it sig figs because it's a lot easier than saying significant digits. And sig digs just don't feel right, okay? It just don't hit the same. So excuse me, I'm going to say sig figs. I'm going to write significant figures. It's the same thing as significant digits. The significant figures in a measurement have all of the known values plus one uncertain digit, which is always the last one. So if we take our example from before, where we said scale number 2 gave us 1.2695 grams of our metal, this last digit, that 5, that's the uncertain digit. It may fluctuate on the scale. It may go up to 7. It may go down to 4 or 3. It's, take it with a grain of salt. The 1.269, take that to the bank. The 5, it's there, but it's not as certain as the other digits. When you're taking a measurement, particularly length or volume, where you're reading a measurement off of a ruler or some kind of graduated cylinder or something like that, you have to take into account how much certainty you actually have with your instrument. So we've got two rulers, ruler A and ruler B. Take a moment, figure out which ruler has more uncertainty, ruler A or ruler B. This would be a good time to pause it, maybe think about it, write it down in your notes, take a mental note in your brain, and then I'll talk about it. So I'm going to pause for a second, and then I'm going to talk about it. So which ruler has more uncertainty, ruler A or ruler B? Well, we said that you have to go with whichever one that's going to give you the fewest decimal places. That one's going to be your most uncertain instrument. Ruler A, we just see the centimeters, 0 through 10. Ruler B, we see centimeters, but we've also got millimeters marked off. So that means that ruler A has got to be the most uncertain out of the two. We can't get a whole lot of information here. Now, how many sig figs would each measurement have? Remember that we have to take everything that we see plus that one uncertain digit. In this case, with ruler A, we know that we've got some kind of 4, right? And now we need to do our uncertain digit, which I'm going to use red for. It's somewhere between 4 and 5. If we guess that this is about 4.5, like that mark right there that I made, then maybe you'd say that that's about 4.3 centimeters. But you see how I'm like, aside from that 4, bruh, I don't know. Maybe it's 4.3. So that's our guess for ruler A. For ruler B, we can say with confidence 4.2 because we've got this 4 and then we've got these 2 dash marks here, which means 2 millimeters, so that's 0.2 centimeters. Now we have to do our uncertain digit. We got to guess. Now it's between the 2 and 3 here on the tick marks. Keep hitting this button, y'all, my bad. I'm rusty too. Okay. So it's between here. I'm going to call that 4.25, okay? Doesn't get any better than that. But you see how we have more significant figures from ruler B than we do ruler A. So ruler B, every measurement that you take should have 3 significant figures, 3 sig figs. And from ruler A, you should have 2 sig figs. One that you know for sure, and one that you're kind of guessing on. B, you have 2 that you know for sure, and 1 that you're guessing on. We'll do more practice of this kind in the live session next week. Or, well, it should be next week. You're supposed to watch it beforehand, but I understand. All right. See, I did all of this, so you can actually go back through and do another example. So let's say that instead of this metal bar, that you had this black line. And you can estimate on your own ruler A and ruler B, and remember which one should have fewer significant figures. So again, we'll do some more examples like this in class. We talked about length measurements. We're using a ruler of some kind. We're seeing how many centimeters or meters, You could use the system that we use, the imperial system, measure yards or feet. But I'm not going to hold you. I don't remember all those conversions. The metric system is so much easier, and you'll see that when we go over chapter 2. The second type of measurement that we have is mass measurement. So the mass measurement just tells you how much matter it contains. I'm going to underline the pertinent details of this definition here. It measures the amount of matter that an object contains. And mass, what's great about it is that it's not affected by gravity. So you go to the doctor's office, you step on a scale, that's affected by gravity, right? But if you were to step on a really large balance, not affected by gravity. So no matter what time of day, no matter where you are, you're going to get the same reading on that balance that gives you a measurement of mass versus your weight on a scale. And remember, we're talking about some kind of grams here. The third type of measurement is a volume measurement. We're talking about some kind of liters or milliliters. And volume just tells you the amount of space that's occupied by whatever matter you're interested in. You should have a rough idea of what these different measurements are: length, mass, and volume. What is it that they measure? Mass, you're talking about the amount of matter in an object. Volume, we're talking about the amount of space. The length measurement, we're talking about how long or short something is. For volume, some of the different things you might see in the chemistry lab is a graduated cylinder, syringe, burette. Now, you're not going to have to know these for the class, but just know that I may give you a picture or something with a graduated cylinder that has the number of milliliters marked, and maybe you'll have to read that and give an estimate, giving with the right number of significant figures. So just like we did with length with the ruler, you can do the same thing with a graduated cylinder or a flask or something like that to estimate the volume. If you're a cook or you like to bake, or your mama or your grandmama likes to bake, then the things you have in the kitchen to measure volume are like measuring cups and measuring spoons and stuff like that. So it's the same thing, it's just for the metric system in the lab, and you don't want to eat what you make. So we covered the types of measurements. If we're looking at an instrument like a ruler, how many significant figures can we get from that? But now we need to figure out how many significant figures are in a given measurement. So we're given a measurement, and we have to look at it and know how many digits are significant. So the first rule when you're determining the number of sig figs is you count the number of digits in the measurement from left to right. You start with the first non-zero digit. So we're going to use this one as our first example, 0.097 grams. You're going to start counting here with the 9, the first non-zero digit. There's 1, 2. Pretty simple. 2 sig figs. Everything that comes after that first non-zero digit, you're going to count as significant. So if I added a 0 here, that would be considered significant, and I would say that there were 3 sig figs. However, there are placeholder zeros, which we're going to get to in a minute. Let's do the second example, 1.907 milliliters. How many sig figs? We start with the first non-zero digit, that's here with the 1, and then we count. 1, 2, 3, 4. There are 4 sig figs here. I want to draw your attention to this 0. This 0 is sandwiched between the 9 and the 7. That 0 is not a placeholder, okay? It's measured. It's sandwiched between some numbers. It's measured. In our first example, when I added on that 0 at the end, remember, that's not a placeholder either. In this case, this 0 is our uncertain digit. Remember that we said each measurement has an uncertain digit at the end. So if I add on 5 zeros at the end, that last 0 that I add, that's the uncertain digit. All the other ones are measured. So them zeros can be tricky. In this third example, 1,970 centimeters. Start with the first non-zero digit, and you don't count placeholder zeros. There's no decimal point or anything here. So this 0, that's a placeholder. We don't count those. Because if we didn't have the 0 there, it wouldn't be 1,970, it would just be 197. So we have to put a 0 there so that we know it's 1,970. But that 0 is not significant. We would just count 1, 2, 3 sig figs here. We'll do some practice, and I'll give you a couple that you can do on your own, and you can ask questions in class. So what I want you to try let's try this one. 19,070 kilometers. How many sig figs are in that? And then how many significant figures are in 2.1090 grams? Now I'm going to be real with you. With some of this, I'm actually making it up as I do the video. So these extra practice problems, that is what I'm giving to you off the cuff for you to do as practice. You can come in and ask during office hours or during the live session, hey, how do you do this? But don't ask me and just expect me to remember the problem, okay? I have 3 small children. Number 4 is on the way. Talk about mommy brain. That's me. So I promise y'all, I'm qualified, but sometimes I just forget. Okay? So give me some grace. Always remind me what class and give me the whole story of what it is we're going over so I can be 100% with you. Okay? All right. So we talked about rule number 1. We talked about how to count the significant figures in a measurement. Rule 2, exact numbers. We've got to talk about what an exact number is so I can tell you about what rule number 2 is. Significant digit rules don't apply to exact numbers. So in this picture, you see some quarters. How do you figure out how many quarters there are? You count. 1, 2, 3, 4, 5, 6, 7. 7 quarters. Anything that you figure out by just counting, that's an exact number. So we'll write that here. You can count it. So if you see something like 7 coins or 8 chocolate chips, that's an exact number because you got it by observation. Oops. I guess I should go back here and add rule number 2. Exact numbers do not count for significant figures. Exact numbers are not measurements. So they do not have significant figures. Anything that you can count, we didn't use any kind of an instrument to figure out that there were 7 quarters there. You can count it, it's an exact number. So now I want you to check your understanding. Identify each number as a measurement or an exact number, and then indicate how many significant figures are in each measurement. This would be a good time to pause and do this in your notes. I'm going to go over it. We're going to do more examples in class, but really actually try it instead of just watching the lecture and writing it all down in your notebook. Because the point isn't for you to just write down pretty notes, but for you to actually understand it and be able to do problems. So go on and pause. I'll be here. Alright. So I'm assuming that you paused and unpaused. Don't give me reason to not trust you already. I know somebody ain't paused, but that's okay. It's going to show. I don't want that to happen to y'all, but it's going to show. You need to do practice problems. Let's split off these 3 different problems here. The first one, you're identifying whether or not it's a measurement or an exact number. 460 grams of flour. We see grams. That's a measurement. What type of measurement is it? That's an extra question. It's mass, okay? So whenever you see one of those units that comes after a number, you know that it's a measurement. Now, how many significant figures are in this? We're going to start with the 4 because that's our first non-zero number. 1, 2. Do we count this 0? Is it a placeholder 0? Or is it significant? It's a placeholder. If we didn't have the 0, the number wouldn't be the same. It's a placeholder 0. There's no decimal point. It's not significant. Number 2, 0.250 pounds of butter. Yeah, I threw in a different unit. That's all right. That's a weight. Okay, it falls under the class of measuring. It's not exactly mass, but we can still throw it in there kind of as that same similar category. So it is clearly a measurement. And now we need to figure out how many sig figs. This first 0, that's a placeholder. We ain't counting that. That's not a non-zero number. We're starting here with the 2. There's 1, 2. This last 0, placeholder or no? It's not a placeholder. That one is measured. Remember, the last digit is the uncertain digit when we're looking at a decimal like this. So we actually have 3 sig figs here. Number 3, 10 chocolate chips. I was hungry probably when I made this. I've been wanting to make some chocolate chip cookies. It shows flour, butter, chocolate chips. Come on. I'm a mom, y'all. So I'm sorry. I'm probably going to make all kinds of analogies using kid stuff. I'm going to try not to. I'm going to try to be a grown-up for y'all. But it's probably going to come out. 10 chocolate chips. Do we need to use any kind of instrument to figure out how many chocolate chips there are? No, unless you count your eyes. Your eyes ain't an instrument. This is an exact number. You need to be able to do that. Identify the type of measurement, whether it's a measurement or an exact number of significant figures. You don't have to explain to me why you said 2 sig figs versus 3, but you should know that so that you can come to an answer. If this was difficult for you, make sure that you write down your struggle point or what you didn't get so that you can bring it up in class. That's what we're going to use the live sessions for. We're going to kind of do a brief recap, and then we're going to do some practice problems together to make sure everybody gets it, and that's the time when you can ask your questions from the lecture. All right. So we've covered measurements, significant digits, how to figure out how many you have, and we talked about placeholder zeros, exact numbers. Now we have to talk about rounding off non-significant digits. Most of the time, when you take a measurement and you're doing some kind of calculation, you're going to generate a bunch of non-significant digits. So you do some kind of calculation, and then your calculator spits out all these numbers. Don't give me all those numbers. I don't want them. It's too many. I don't have space. I do not have room. I will not take. You have to round. And there are rules for rounding that we're going to get to. But first we're going to talk about just how to round a number in general. So don't give me all the numbers, because it's going to be wrong. I'm going to be mad. It makes me mad to see all these numbers. And, I don't want to see it. Okay? So the rules for rounding numbers. If the first non-significant digit is less than 5, then you drop all the non-significant digits. What does that mean? Let's say that we had 1.237, and we're trying to round this 3 here. We look at the 7. Is it less than 5? No. So we got to do something else there. We're going to have to round up, and we'll talk about that in the next step. If it were 1.234 and we're trying to do this, we're looking at the 4 and saying that's less than 5. So when I round, I just drop off that 4. That 4 is gone. If it's greater than or equal to 5, like in our 1.237, when we're looking at the 7 for rounding, then you're going to increase the last significant figure by 1 and then drop everything. So that 1.237 would become 1.24, and we would get rid of the 7. The 7 has done its job. If you have a calculation where there's, multiplication, division, and all the things, keep all of your non-significant digits until the last thing you do. Don't round until the end. That's what that means. It will affect your answer if you round in multiple places. And that can sometimes be the difference between getting the right answer and getting the wrong answer. So make sure that you don't round your answer until the end. So let's do some practice. Let's round this measurement to 2 significant digits. We've got 4, 8, 4, 5, 7 grand. If I want 2 significant digits, where is that going to land me? Right here. Okay. So I'm looking at this 4 to tell whether or not I should round up or just leave it alone. We said that if the first non-significant digit is less than 5, which that's what 4 is, then we just drop the non-significant figures. What does that mean? Don't just write 48. 48 is very different from 48,000. This number has 2 sig figs. The rest of these zeros, they're just placeholders. So this number has 2 sig figs. It's properly rounded because we looked at the 4, which was our first non-significant figure, and we rounded to 48,000. What's the length of this blue line in centimeters? This is very similar to what we did in the beginning. Take a second, pause, and try this one for yourself. All right. What we're trying to do is figure out, okay, what is this measurement? It's somewhere between 4 and 5 centimeters, pretty close to 5. And since we have the centimeters and these millimeter ticks, that means that it needs to be 4 point something something for our answer, with that last something being our uncertain digit. It's between, so we have the 4 point, it's between the last 2 tick marks here. So we'll say 4.95 centimeters, something like that. Now that's just, we didn't round anything yet. That's just determining the length of the blue line. Now, I want you to round to 2 sig figs. 2 significant figures means that we're going to round this 9. We're going to look at the 5. That 5 equal to or greater than 5, you got to round up. How can you round up past 9? You got to change that to 5.0. Okay? So that's the only time where it's a little bit trickier, and you have to say, all right, I know I'm supposed to be working on this 9. Ain't nowhere to go but to make this a 0 and bump up the next number. So 4.95 rounded to 2 sig figs is 5.0. And notice this 0 is significant. We'll do more practice, so don't worry. Let's get on to some rules about adding and subtracting measurements. So when you have a measurement, your answer, the number of sig figs that you report, is limited by the measurement that has the most uncertainty. And we said that that translates to the fewest decimal places. Which one of these has the fewest decimal places? This top boy, it's only got one decimal place, okay, the 10th place. So that means we're going to go through and add, but our answer can only have up to the 10th place. What I like to do is set it up like this and draw a dotted line down so that I know where it is I have to round. So let's do the addition, old school by hand. There's our decimal point. Okay. I hope that's right. I'm recording this early in the morning, so sometimes the brain don't add right. But let's assume it is. And now this dotted line tells me I'm trying to round this number. So I look at the 3 and say, all right, what do? Do I stay at the 6 or do I go up? 3 is certainly less than 5, so we're just going to leave it alone and report the number as 115.6 grams. Notice it's got the same number of places as the most uncertain answer. That doesn't mean that it'll always have the same number of significant figures, but it will have the same number of decimal places. And I know I keep saying it, we will do more practice in class. So if that doesn't make sense, don't worry. There's going to be plenty of opportunities for you to practice and get it right. Multiplying and dividing measurements. Your answer is limited by whichever measurement has the fewest significant figures, which is different from the most uncertain measurement. So the first thing you got to do is figure out how many sig figs are in each measurement. This first measurement, we've got 3 sig figs. 7, 2, and 8, they're all significant. In the next measurement, there are 2 sig figs. That means that our answer has to have 2 sig figs. Now, I already put this one here because I knew I was going to struggle. I'm not going to sit here and try to embarrass myself and do this by hand and take 20 minutes to do some math that a calculator could do in 2 seconds. Okay? I promise I can multiply, but I'm not going to put y'all through that. So, 2 significant figures. That means that we need to round this 3. We look at the 4. Is it greater than or equal to 5? No, it's less than 5. So that means we're going to just drop everything. When we report our answer, it's simply 33 centimeters squared. And you see how I boxed that? Because I wrote a bunch of stuff. When you're doing your homework and your exams and stuff like that, help a sister out. Box your answer, because sometimes the answer is not where I would guess it would be. So make it easy for me to grade. Please. Please. If you like me already, please make it easy for me. Help me help you. So let's say that you have some measurements and you need to do a bunch of different operations. You need to add and divide, or you need to multiply and then subtract. You identify the measurement that you have in the given information in the problem with the fewest significant figures, okay? Then you perform the calculation, whatever it has to be. Then you report your answer with the same number of significant figures, as that most uncertain measurement that you had in the problem. And that's kind of a little bit abstract, so we're going to do a problem together. Let's say that you have 3 boxes and they all have the same dimension. It's 3.5 centimeters by 5 centimeters by 10 centimeters. What is the combined volume of all 3 boxes? First step is figuring out volume. Which in this case, we're talking about length times width times height. Then you use that volume equation to calculate the volume of one box. Then you can multiply by 3 to get the combined volume. Now, I'm not going to do this problem for you. I want you to do it. We're going to do this example and then some variations of it in class to practice with our significant figures. But notice how I wrote out the different steps of how to solve the problem. That is going to be a very useful tool for you, especially as we get to the later chapters like chapter 8 and 9 and 10. Learn how to write out your strategy so that you don't get lost in the numbers. We'll use that kind of again in chapter 2, but chapter 2 problems are not going to be as complicated. But always write out kind of your strategy, write out your work. It helps me to grade you and give you more partial credit if you get the wrong answer. And it also helps me see where the issue is, so I can write you a little note, hey, so-and-so, you were good up to here, but then you flipped this. So the more you show me about your process, the more I can help you if you don't have it 100% correct. So try this. It shouldn't be a hard problem, but it's really just getting you to understand the doing multiple operations. So in this case, we're multiplying and then we're multiplying again. So they're not different operations, but there's multiple. And you have to carry your non-significant figures through till the end. You're also tasked with figuring out which one of these values which one has the fewest significant figures, okay? We'll talk about it in class, so don't worry, but try it in your notes first. And we're going to switch gears. We talked a lot about significant figures, how to add, subtract, multiply, and all those things, what measurements are. Now we got to talk about some other numbers because we're building up to talking about scientific notation. Exponents, let me try saying that again. Exponents are used to indicate that a number has been multiplied by itself. So if you have 4 times 4 times 4, that's 4 to the third, or 4 cubed, which is equal to 64. The exponent here, we got 4 to the third. This little 3 up here is the exponent. This whole thing, the 4 to the third, is the exponential number. So if you had 2 times 2 times 2, that's 2 cubed, which is 8. This is just brushing the cobwebs off, just in case you haven't had math in a little while. Now, powers of 10, we're talking about a number when 10 is raised to an exponential power, okay? So we could have 10 to the 5th, or we can have 10 to the minus 5th. If your exponent is positive, then this number is going to be greater than 1. If your exponent is negative, it's going to be less than 1. So think a decimal. I also have this handy chart here that can kind of help ground you, and it'll give you some different visuals for exponents and what they look like written out as, 10 times 10 times 10 or whatever, and what the actual ordinary number is that you might be used to seeing. So if this is helpful to you, use it. If not, move on. All you need to remember is that if you have a positive exponent, you're going to have a number that's greater than 1 when we're talking about powers of 10. And if you have an exponent that's negative, you're going to have a decimal. Something that's smaller than 1 is going to be a fraction. When we put exponents and powers of 10 together, we can use scientific notation. So oftentimes in science, we have really, really big numbers or really, really small numbers. And I don't know about you, but I hate writing all those zeros and counting all those zeros. Because sometimes you get lost. It's easy to get lost in the zeros. We don't want to do that. We're going to use significant digits, and we're going to use powers of 10, and we're going to write scientific notation. Let's talk about the significant digits. That's going to come from your measurement. And it has to be at least 1 but less than 10. And that'll make more sense in a minute. But this first part cannot be more than 10. All right, so you can have 9.999999, but you can't put a 10 in that bad boy, okay? And I'll show you how to figure out what goes here. Then you're going to have your times 10 to the n, which is your power of 10. So let's say that we have this number, 0.000078 grams. And we want to write it in scientific notation. The first thing we have to do is come up with that number that is at least 1 and less than 10. So we're going to move our decimal point from where it is. Let me change colors. We're going to move it to here. We're going to make a 7.8, okay? That's our significant digits portion. Now we need to figure out the power of 10. We moved our decimal place to the right. So that means that our exponent, our n, is negative. And then you count how many places you moved it. So we said 1, 2, 3, 4, 5. -5. The other way that you can figure out the sign of your power of 10 is to just look at the number. If your measurement is 1 or greater, then your n is going to be positive. And if you have your measurement that's less than 1, I'm not writing the whole first part again, then your n is negative. So when we look at our measurement, this 0.000078, that's less than 1. So we know right off rip that our n, the power of 10, is going to be negative. You just have to count the number of places that you had to move the decimal point to make it, to make that first number here with the significant digits. We'll do some more examples, so don't worry. Now let's do a really big number, okay? There are 26, I'm not even going to try. That's a very large number of helium atoms in 1 liter of helium gas. We're trying to express this number of atoms in scientific notation. And remember, we're trying to get to this format. First step, you got to make this. So we look at our number, and remember, if you don't see a decimal point at the end, it means that it's implied that there's a decimal point here. So we have to move this decimal point all the way over this way to the left and place it between the 2 and the 6. That's going to give us 2.68. Now we've got to figure out our n. Is it going to be positive or negative? We moved it to the left. We're looking at this number. It's a real big number. It's definitely bigger than 1. So that means our n is going to be positive. Now we just got to count how many spaces we moved to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Don't forget your units. We said these were atoms. So 2.68 times 10 to the 22nd atoms are in 1 liter of helium gas. Let that simmer. The hardest part is the counting. And you notice how I made little tick marks above each digit? That helps you keep your place. So whatever works for you, just make sure that you do that consistently. We'll do one more example together. I want you to pause and try this one, and then look at the answer. I know some of y'all ain't paused. I'm telling you, if you don't pause and try it, it's going to be struggle bus. Don't blame me. I told you, pause. Pause and try it. And this is on YouTube. So you can pause it, rewind it, do all the things. It's not like class where if you miss it, it's just gone. This is the wonderful world of the internet. So you can pause it, rewind it, rewatch, all those things, all right? Okay. So we've got the typical length between these two atoms, carbon and oxygen, in a molecule is a very small number of meters, okay? Let's express that length in scientific notation. Off rip, we can see that this number is less than 1, so our n is going to be negative. Remember the format for scientific notation, and this first number, this first part, has to be at least 1 less than 10. We're moving our decimal point to make that first number 1.16. You got to keep all those significant digits in there. We know that our n is negative. We just need to figure out how many, what that number is. So it's negative something. Let's count how many of these places we've skipped over. 1, 2, 3, 4, 5, 6, 7. And we said that this is meters. 1.16 times 10 to the minus 7. So always do the mental math to double check. This first number has to be at least 1 less than 10. If your measurement is 1 or greater and is positive, if it's less than 1 and is negative. Make sure that's in your notes. You're absolutely going to be doing scientific notation. So please, please, please make sure that you understand it. You're going to be using it now, and then it's going to come back again towards the end of the class. We'll do a review, but you need to make sure that you can understand it. You can read it, and that you can take a number and write it in scientific notation. This is just kind of a slide that you can either print out and put in your notes, but it details what we've been doing. I didn't want to just put up the words. I wanted to kind of show you the process and then give you the steps later. Okay? So I'm not going to go over this slide. This is what we've been doing about how you apply scientific notation, how you take that measurement and write scientific notation. Finally, we're going to talk about scientific calculators very briefly. So we talked about scientific notation, which uses exponents. You need to be able to put in an exponent in your calculator. Normally, you'll see on your calculator, if you have an exponent as an answer, you'll see some kind of an E in there. So in this case, I just use the Windows calculator. 1.65 E plus 8. This E means exponent. And this plus 8, that's your N. So it's a positive 8. So you can translate that to 1.65 times 10 to the 8th. Now how you would punch it in on this calculator is you would do 1.65. Then you would hit the exponent button followed by the 8. And that's different depending on which calculator you have. So make sure that you know how to put in exponents on your calculator. If you're not sure, you can Google it. You can ask me. There's a lot of calculators out there, and you need a scientific calculator. It doesn't have to be graphing, but it needs to be a scientific calculator so that you can do exponents and stuff like that. Lastly, this is your chapter check-in. It's posted on Blackboard, so you don't have to take it down from here. But I wanted to put this in as the final slide to remind you that we aren't doing this in vain. Going to be some assignments for you to practice on. So this chapter check-in, along with the Mastering Chemistry homework and quiz, are going to be due no later than Sunday, which is August 30th at 11:59 p.m. Eastern Standard Time. So there is a good amount of time for you to do this, ask your questions in the live session, come to office hours if you need additional help or if you just want to say hi and introduce yourself, and then submit your chapter check-in on Blackboard. You can set up your Mastering Chemistry. You have a 2-week free trial. Please prioritize purchasing the Mastering Chemistry subscription because these assignments are graded. They're a good portion of your grade, and you want to make sure that you're not behind. So please, please, please work on that diligently. I will try not to give you super long assignments because that's just wrong. But I do want you to make the time to study, go through the homework. You get multiple attempts to answer the homework questions. You don't get multiple attempts for the quizzes. So make sure you get that homework down so that when you go to the quiz, you have it right. We'll talk about this in class more, particularly the Mastering Chemistry part and how to create an account. So don't worry about that for right now. We'll talk about it in class. Until then, if you have questions, feel free to email me, or you can just write it down in your notes or have like a questions page after each chapter, and then bring them up during the live session. Please don't be afraid to ask questions, because if you don't ask questions and then you're lost because nobody else asked it for you, you're wasting your money. So don't waste your money, okay? Ask questions. The only questions that are dumb are the ones that are not asked. That's probably not exactly true, but I'm going to say that for right now, okay? So make sure that you ask questions and you get it. Get your money's worth. That's what I'm here for. I'm going to get the same check either way. So you may as well ask the questions, right? Okay. Good luck. I will see you in class. And if you have questions, like I said, make sure that you let me know. Alrighty. Have a good one.